and we will get started. Let's go.
This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Hi, I'm Lee Bortons, and it's Monday, January 9th, 2023. Welcome to the Math Map, where Kirsty Gilpin and I discuss a math concept each week from our soon-to-be-released math curriculum for families with students in the Classical Conversations community. Kirsty and I spent a lot of years discussing the difficulties of math education, and we found there's many reasons, but they can all be identified, and that means they can be overcome. I have an engineering degree because I'm organized and a problem solver, not because I'm naturally good at calculating or mathematics. And teaching our 4 sons math every day for 30 years and working with the Math Map team for 5 years is why I actually am now very good at calculating. Kirsty, can you share a little of your background?
Sure. I think it's funny that you talk about being an engineer, because that's where I started, and then I could not attend to the details needed for my basic engineering courses, and so I switched to math and computer sciences, which seemed a little bit more forgiving. And so we kind of came at math from the two sides, and I think maybe that's one of the things that makes us such a good team.
Yeah, and so I think our stories just kind of highlight that there's just so many different kinds of personalities that can enjoy mathematics and engineering and orderliness and just the harmonics and the stars and all the things that go with it. So as way of introduction, this book club explains a little bit different. I hope to see you on our other book clubs on Thursday evenings at 7 and 8. We're working on Words Aptly Spoken and abolition, overcoming the Christian establishment on education. And the Words Aptly Spoken is a book a week. And the other one, it's called Unfragmented, is a show. It's a book a month. They're difficult books, and so we want to go slower with those. But the Words Aptly Spoken are all curated curriculum for our high school students, so a little more approachable for us. But math, we need to really just start to help people enjoy math. And so this club is around the Math Map, which was not released yet. So you're going to be using, if you want to, the beta Classical Conversations or on ccconnected.com, I should say. And we're going to spend 30 weeks discussing the Math Map topically. We're not going to be doing a lot of math and calculating. We'll talk more about the whys and hows of just math pedagogy and math education in general. And so we'll be taking the summer off. So this winter, spring, we're going to be talking about the first 15 lessons, which are going to be used by our pilot in the fall. And then during the fall, we'll work on our second 15 weeks, so that the parents and tutors who want to hear more from Kirsty and I about the Math Map have plenty of time to prepare and to access the recordings and those kinds of things. So the way you access the Math Map is you need to be a member of Classical Conversations, because it is on CC Connected. Let people know they don't have to be a CC student or a member of CC Connected to participate. We're hoping to encourage anybody with any questions about mathematics and just how it helps us to know God and to make Him known. So if I went too fast later on, we can discuss again how we can access the materials. So before we do that, though, we're going to, by way of introduction to the Math Map, we're going to jump in. We'll see how things are run. And each week, we're going to consider a quotation that's part of the exordium for the Math Map lessons. So tonight, we are discussing Ex Nihilo, which is the first lesson in the Math Map. Hopefully, we're going to talk about why we love zero so much. But Kirsty, could you introduce the Ex Nihilo to us by reading the cover quotation? And we're going to talk about what that says. And then those of you who have the PowerPoint, if you can see that in front of you, you might need to blow it up to be able to read it. But you can read along with Kirsty. So thanks, Kirsty.
There is no ground for supposing that matter and energy existed before the Big Bang and were suddenly galvanized into action. For what could distinguish that moment from all other moments in eternity? It is simpler to postulate creation ex nihilo, divine will constituting nature from nothingness. And that's a quote by E.T. Whitaker, who was a mathematician. And he's really looking at this, from a mathematician's perspective, saying there's two options here. We can either believe that there was this swirling mass, and then one day something happened and it went from this swirling mass of stuff to the creation we know now, or we can believe that there was a creator who existed before all of this and created all of this from nothing. And he just believed, as a mathematician, that it made a lot more sense to believe in a creator. So I thought that was a great way to open up our quotes.
Yeah, because it's amazing how many people who study math and get really good at it just love creation, the creator, and all the mystery and beauty. So Whitaker is one of those folks. So here's the thing, we introduced that this week. Next week, when we're doing number notation, we're going to pause and actually ask you guys to weigh in on what the quotation is. And sometimes what the art is on the cover page, as well as the reflection that we have there. But Kirsty and I said we will just read it this time and set us up for next week. So please look ahead to that, and then we would welcome your conversation. Now, when we get to the actual part of this, when we're all talking to one another, you're still welcome to comment on it. Okay, so thanks, Kirsty. So Kirsty, I want to talk to you about two different things first, while we give more people time to get on, and also to kind of, as our own exordium to warm up the group of people here with us. One of the things that we've identified that makes math hard is that it's a foreign language. It's a universal language. And it has many assumed definitions familiar to mathematicians, but not to the general public. So it can be confusing. Let me give an example, and then I want Kirsty to really weigh in on how math's a foreign language. This afternoon, when we were working on writing the math map with one of the young folks that's helping me, we got really frustrated because you guys all know what just parentheses are. Well, they're used for a lot of different things in math, and we'd gotten to a place where it was really difficult mathematics, and there were those parentheses again. And the way the problem was written, you couldn't tell out of context whether it was a coordinate point like XY or an actual parentheses in kind of what order of operation in an equation. Those are the kinds of things that mathematicians take for granted and think are just obvious and easy, and they are not. So Kirsty, can you describe some of the issues with just understanding math?
Sure. I always like to tell people about my trip to Paris many years ago, when I had a little bit of French. And of course, I tried to use it, and people immediately identified me as an American and started speaking in English to me. And one day we were in a store, and this lady saw me and just started speaking French. And I was so excited because I finally looked Parisian to somebody. But I had really no idea what she was saying, and I couldn't answer her. So even though I had that smattering of French, I wasn't fluent. And in order to communicate to somebody, I needed to be able to stop and decode what they were saying, and really try to figure it out, right? So if I was going to move to France, it would take me a while to actually be able to speak to people and carry on a conversation without a lot of thought. And math is the same way. If you think about your young students when they're just learning to read, right? It's laborious because they're sounding out every word, and it goes slowly. And sometimes you want to say, you've sounded that out 3 times, just say the word, it's cat, right? Mm-hmm. Because to us, we don't have to decode anymore. We're just doing it on the fly. Well, with mathematics, it is a different language. And there's 2 parts of that. There's one, just like you were talking about, coordinates, and parentheses and order of operations. Those are all words that we may understand the word, but not understand the meaning unless we know what the definitions of those words are. So that's the first thing, is the specialized definitions that go along with mathematics that you need to know. But to make it even more confusing is that we use a lot of shorthand. And we like to say that math is the only place that we use shorthand, but let's face it, I remember my first year in CC when people were talking about CC and C3 and all these other things, and I had no idea what they were talking about because everybody was using a shorthand that was familiar to them, but not to me. And so math is the same way. There's all these symbols and shorthand ways of communicating that if you're not familiar with them, it takes you time to decode it, right? So if you see a math full of mathematical notations, you slow down because you have to decode what they mean. Make sure you understand the definitions, right? What do the words mean? What do the symbols mean? So what word does that symbol represent? What idea does that symbol represent? How does it go together? What does it mean? And once I'm done with all that decoding, then maybe I'm starting to make sense of what the expectation is I'm supposed to do. But I don't think we always give ourselves credit for the effort that goes into that decoding. And sometimes maybe we need to think of ourselves as our beginning readers and remember what it sounds like for them when they're just learning how to read. And until we become fluent in math, that's what it feels like for us. And I just want to put a little disclaimer out there that very few people are really that fluent in math. Even in my calculus class that I took last year, even though I've been doing math for so long, I've been teaching it and studying it, that in this calculus class and these pages full of notation, I would have to stop and slow down and decode and then understand and then move on. So I just want to be really clear that there's no magic point that you reach where you're like, oh, I'm fluent in math. That even our most advanced mathematicians, for most of them, there's still a period of time of decoding if they're not working with the things that are their daily work.
Good. So as we go through the curriculum and its topics this year, we're going to talk a lot about decoding and notation and language, because I think that part's approachable to parents if they just recognize the parallel between learning how to read your native tongue as well as this universal language that's read by people all over the globe. So another thing that we've identified is that there's no general canon to mathematics. It's kind of funny because people, ask them to describe mathematics. They very often will say it's orderly, yet we're not very good at saying what the order is. We are more familiar with other canons, things like the books of the Bible or amendments in the Constitution, or maybe lines in a Shakespeare play that the community's putting on, that we have a way of communicating with each other and it's stable. And that's kind of what I mean by a canon. So what we're going to do is we're going to look at our canon, which we call the math map. And each week we're going to discuss a small section of the math map in order to explore the underlying structure of all of mathematics, whatever language you are studying it in. So Kirsty, could you explain more about the math map that we have in front of us on the PowerPoint? And let us just know what section we're going to talk about. And maybe what we're going to talk about next week so people can start thinking about it.
Absolutely. So we're going to start tonight talking about those multicolored bars along the top that are so pretty. All of those colors. Maybe you don't necessarily think of mathematics being colorful, but that bar across the top really represents the order in which students would progress through the math map. So I'm not going to try and talk about the whole thing this week, but if you look at that on the purple end where it says digits, that's where we're thinking about our very youngest abecedarians, and the other end, that dark blue, is our challenge for our graduates. And so we see there's this whole range of ages that we're going to be talking about in the math map. And one of the examples that I like to use when we think about how we can look at things across all these different ages and how grammar, dialectic, and rhetoric plays into that is by talking about trigonometry, because that's something that a lot of people who maybe didn't have a great high school math experience immediately kind of go, oh, I remember something, but it's fuzzy, right? And a lot of people remember the word sine, cosine, and tangent, but don't necessarily remember what they meant. because the way that traditional education presents it is by saying, okay, this is our week or 2 weeks that we're going to do trig. And so I'm going to tell you what these words are, and we're immediately going to use them. And I'm going to expect you to memorize and use things all at once and figure it out. But what the Math Map does is it says, okay, trigonometry is a fantastically useful skill for everybody. It really is one of the most useful mathematical things that we can use in our everyday real lives. So how can we identify the grammar? Well, we can talk about what do sine, cosine, and tangent mean. And I can give you words like the sine is the opposite leg over the hypotenuse, or more words that the sine is equal to the length of the leg opposite to an angle over the hypotenuse, right? And so now I'm giving you some words, and your 4-year-old, your 6-year-old, your 9-year-old can all memorize what those words mean. They may not know how to apply it or what they refer to, but they can memorize, right? So they can get that grammar in. And then as they're entering into those challenge years and they're becoming dialectic, and they go, wait, you've got a picture of a triangle and you've got these words, and the words that you're using are the same words that go with this triangle. And now I'm having this dialectic moment because I realize that this right triangle and these words go together. And so I'm not ready to do anything with it, but I'm having that dialectic moment where I'm taking these ideas and putting them together. And I continue to practice, and I continue to build these connections. And then as I become an older student, all of a sudden I go, oh, I know how to set my ladder up outside to be safe, or I know how to measure that angle to cut the crown molding, or any number of different things, right? I want to measure the height of that tree. I can do that using trigonometry. So there's my student becoming rhetorical. And so we've taken one skill, this idea of trigonometry and the sine, and we've said, let's first look at the grammar, and our youngest students can memorize the grammar. We're going to then help our middle school students to build those connections, and eventually our oldest students become rhetorical. And we're going to do that for all of these ideas in mathematics. We're going to say, what's the grammar? Help our students ask the questions to become dialectic, and ultimately, hopefully, we'll see our students becoming rhetorical in at least some of the areas of mathematics that we cover.
When you're describing the grammar part, I was wondering if maybe Charles Schulz, when he made Charlie Brown, you know, and all the adults talk in wah, wah, wah kind of voice, if he maybe got that idea from his math class. So what's interesting about what we're trying to do is prevent that in our children and be using the vocabulary of their childhood. In other words, increase their vocabulary in math when they're young, so that when they're older and they're processing faster and they're trying to get through things, and you know, they tend to do more of the things they're interested in rather than the things that you know, just they suck in everything when they're little. So we're hoping that introducing to the vocabulary earlier will make it so they don't just tune out when people start saying words like hypothesis, right? Mm-hmm. Or hypotenuse. How about I get the word right? All right. So we're ready to begin our book discussion and include everybody. Feel free to turn on your camera and chat questions and comments at the bottom of the screen, while our able producer, Julie Melendez, selects some questions for our discussion. I'm hoping you guys get to know Julie as well as you get to know Kirsty and I. She'll be producing each week and be in charge of connecting with you guys. So in order for them to think about how to participate, because we don't have math problems here, and probably a lot of us don't have the math curriculum yet, I urge you to go to ccconnected.com and download number notation for next week. We're going to have Kirsty tell us a little bit about the Math Map lesson 1, Ex Nihilo. So she's got that circled on the diagram in front of her. And while we are starting the book discussion, we have a question for you. We wanted to know, now I forgot what my question was. Do you remember what it was, Kirsty?
I think goals for their own home schools, their math goals.
I have these notes, but I'm not following them, and I lost where I was. So if you could think about what your goals are for math education with your family, and hopefully over the year, we'll all get better ideas, as well as maybe change what our goals are, and then see how we can accomplish them. All right, so now that I lost myself, give me a second here. Oh, I was talking to you, Kirsty. I'm going to get rid of this script as soon as I can, guys. All right, so Kirsty, you're going to tell us about Ex Nihilo and just kind of launch some information about why it's called Ex Nihilo. Please define it.
So one of the great things about mathematics is that it allows us to think about simple things deeply, right? And I mean, the deepest of simple things is our salvation, right? That it's simple. The Christian life is simple, but it certainly isn't easy, and it certainly is very deep. And so mathematics is a way to give us some tools to think about simple things deeply. And so in order to do that, the first place to start, right, is at the beginning. And so we think back to the quote where he's talked about creatio ex nihilo, which is creation from nothing. The idea that God created everything that is, right, from nothing. And so we wanted to start every year. So if you notice here, this is a little glimpse back at the math map, right? This is the first week every year. We're going to take time to talk about what is nothing. And I'm not going to get too deep into exactly the math that we're going to talk about in those first 2 weeks. But I want to get you thinking about mathematically, what is nothing, right? It's powerful, right? When you think of nothing, we might think of zero. And the fact that anything times zero is zero, or anything to the 0th power is 1. So there's some really neat things that happen with nothing. And the goal of this week is to start every year by saying, okay, where did God start, and where do we start, and where does mathematics start? Let's think about those simple things deeply, and our little ones can think about simple things deeply. We can ask them some of these deep questions, and we can certainly dive deep with our older students as well. When we talk about what does it mean that God created everything from nothing, let's understand what nothing really means.
So for me, why I love this booklet so much, and the idea of Ex Nihilo when we talked about it with our children, is, well, before I became a Christian, I was at the University of Michigan. I took a graduate course in the number 0 and 1, and for a whole semester, we just talked about those two numbers. And I loved every bit of that course. And it wasn't until years later when I became a Christian that I realized that the only regret to this day that I ever have is that I wasn't a Christian while I was taking that course, because it was very secularized. But it's also one of the things that set me up to become a Christian, because I went to a creation research, or ICR back then, Institute for Creation Research conference, where Ken Ham was speaking when he used to work for them. And I didn't think much about the things that he had to say, but the one thing that connected to me was, well, of course you can create something out of nothing. That was really obvious from a mathematical perspective. And so I'm hoping by the end of tonight, we can talk about how often we do that throughout our day, and we can start sharing that with our children too. All right, so math lovers, I'm going to give you a little bit of an ad, and then we're going to start taking your chats and questions. So before we welcome our friends, I'd like to thank our sponsor, Classical Conversations, ccconnected.com, where the math booklets discussed by the club can be downloaded by Classical Conversations members. Look ahead to the book club schedule, and that's on leebortons.com under the Math Map Book Club tile in the center of my website. And it will show you what weeks we're going to be working on what topics. So if you can work on lesson 2 before next week, that would be wonderful. You would go to CC Connected and download the math map, look for naturals, and it's in beta form. and let your friends know that they can just show up. You don't have to do the booklet. It will just help with the conversation. So next week's booklet is number notation. Okay, Julie, what kind of comments are we getting? What are things people talking about?
Well, I am so excited. There's, 60 plus people on tonight. So
Amazing.
You guys aren't afraid to talk about math after 8. Way to go. One question. So great goals for their families. One, just to love math. I love that because unfortunately I was one of those moms before I started CC. Then I learned quickly I'm not allowed to say I'm not a math person. That we are not allowed to say that because your kids hear you say that and guess what they become. So I love that. Susan wrote, Rachel, do you mind? Rachel Spear, I'm going to call on you. Share that quote and tell me, I don't know if you're able to talk. Share a little bit about that quote that you just heard to elaborate, if you can. Is she going to be quiet on me,
Yeah,
Rachel
okay.
Spear?
Okay.
Oh, there you go. That's okay. She wrote, discovery consists of seeing what everybody has seen and thinking what nobody has thought. It's interesting.
Say it again.
So discovery consists of seeing what everybody has seen and thinking what nobody has thought. That is amazing. I mean, spending time with Lee, that totally describes Lee's mind right there. It really does. If you ride in the car with her for a long time.
That's why I open up to the truth.
That's right. That's right. So one math goal she has just is that they desire to discover the beauty in math and math and the beauty around them. It's so much more than just formulas. So I love that. Who else would like to just talk? We'd love to hear from you and share your math goal. I'm going to scroll through some of these. Anybody want to just jump right in?
My mic was messed up. Can you guys hear me now?
I can hear you now.
I'm so sorry. It was connected to my AirPods. So I just wanted to apologize for being mute.
No, that's good. That's good. Because I know you like to talk.
I do like to talk.
I know.
Yeah, that quote was actually by a Hungarian Nobel Prize winner. And I heard it in a book, and it was a book about science, but we know everything's integrated and you really can't pull science from math. And so it was just this beautiful idea of asking more questions, and that's going to lead to discovery. And that's what I want for my children. I don't really care if they know the formulas at the end of the day, because if we have a good understanding of math, we can solve problems much bigger than what's written in a math book.
Yeah, that's good. I like that it had the word nobody in it, because right away I thought ex nihilo, no, nothing, no one. And how even the smallest insignificant nobody is still somebody. Right. There's so much power, and the person who's the most selfless and the most giving to others and doesn't make much of themselves and chooses really to be a nobody is the most powerful person there is. That was good.
Yeah. Beth Hires, would you be willing to talk a little bit about your answer? I love this. I love this because this is like real life stuff.
So just for a little bit of context, I'm currently tutoring the Abecedarians, and my oldest is 7. But was it now 2 years ago, I just got out of the public school system in Florida, and where I was teaching calculus. So it's like total paradigm shift and everything. But one of the things that has really been transformative as I've made that transition is just seeing the bigger picture of mathematics, the bigger purpose, honestly, of mathematics. Because before it was just like a puzzle you get to solve, and if you're good at it, you can solve puzzles that no one else has. But remembering that God is the creator and the author of mathematics, and that he will not create something to do something that he won't. And so it's kind of talking about zero, like something as simple as like, well, we can't divide by 0. Like, you can't have something without a foundation. You can't just divide something into infinitely many parts and still expect to have something. Like, so it's kind of like how we have to obey these laws that are set before us, and God does not make laws in structure and order that he himself will break. And so it's one of those things where, like, whenever I get into kind of a tizzy, I'm like, wait, you know, because I've got family with some crazy beliefs and whatnot, and it's just like, what do I know to be true? And every once in a while I'm like, well, in math I see this, and I see God's character, you know, just like this way. And I don't know if I'm making sense or anything.
No,
but, okay.
totally. You are.
Because it's just one of those things where, like, I kind of run in a circle now where, like, I'm one of the very few people who's passionate about mathematics, and I see this beauty, and I want everyone in my community to have that. When before, you know, in the school system, my math department, everyone loved math, and I was normal, and now I'm I'm the odd duck, where they're just like, oh, well, we'll come to you with all of our math questions. Like, no, you're their parent. Like, I want to equip you so that you see the beauty too, and you can communicate that and foster that relationship. But sorry, I digress.
No, that is so good.
We love the passion.
I was just going to say, I think, Beth, one of the things that you're pointing out is that there's this in the world, right, in traditional education out in the world, that we've allowed people to build this perception that math is for the ones who can see it, or that math is this, right, special place, right, that if you're really smart or if you're really talented. And one of the things you said, right, is that God created math, and God didn't create math for just a small subject, you know, a small portion of his people. God created math for all of his people. And so I think that that's right, this idea of welcoming everybody into the conversation is really important. And I think that's one of the things that when you really have the opportunity, you know, as you are tonight, to hear Lee's heart about mathematics and welcoming everybody in to see, right, that we can all be a part of this conversation about mathematics, because God created it for all of us, not just some of us.
Mm-hmm. The thing is, Kirsty and I saw Sherry Swiggart's on here. She helps us too at the Math Map in the curriculum development. Oh, I lost my train of thought thinking about my lovely Sherry. What was I going to say? So how math is accessible to everyone, which is something that I want to make sure we touch on tonight, because that's a couple of the goals, was that you wanted to be able to share with your children without spending a lot of money. I saw that go by. And just for the beauty and, you know, the time, and it's, you know, not that it's easy, but that it should be familiar and exciting. And so I would really like it if you could chat, and some of us can pipe in and just discuss, how is it that, like, throw all the math textbooks away you've ever seen. How is it that we know we are designed as mathematicians? Every one of us is a mathematician in my mind. And so let me give an example. Do you have eyes that see perspective and proportion so you don't trip downstairs? What else?
Fruitful and multiply. I keep multiplying.
Yeah.
Wait.
We understand proportions when we're pouring out our cereal into a bowl and deciding how much milk to put in.
Yes. It's like, and you did get a little bit of training, right? Do y'all remember your mom grabbing the milk thing out of your hand a little bit when you were 3-4 years old? But it didn't take much, did it?
We're repetitious. We see patterns, and we do patterns. We brush our teeth. We comb our hair. We do things. There's a pattern to our lives.
And our hairs are numbered, aren't they? What else?
As little kids, we are very good at counting to see who has more.
So more and less amounts, right? Quantities.
Yeah.
How many of you remember holding your toddler's hands and walking and counting steps aloud with them? We do that naturally. Nobody tells, oh, mamas, by the way, grab your kids by the hand and count while you walk with them. We just do it. Why do you think we do that?
Well, it's a way of measuring progress and growth.
Okay. So when you were doing that, Beth, you were thinking, now I'm measuring your progress and growth? Maybe you were.
Because it's like, when are you actually going to be able to walk more than you crawl? So it's comparison.
Yeah. But that natural rhythm, right? Sharing with your child, swinging your arms and shoulders with them while the counting's going on. I mean, anybody who dances or sways, all of you, you got your baby tied to you there, Beth. We all do that, swaying and, right? What else do we do?
Keeping scores. Yes, our children, especially if you have boys, they keep the score for sure.
I was thinking like scheduling, like we know how much time we have in a day and we schedule accordingly. So time and using that time, and sometimes wisely and sometimes not so wisely, but keeping time and scheduling throughout the day.
My 4-year-old wanted to ask me every single day how many days till Christmas. And so she doesn't really comprehend how many days. So we made a little chain, for her to break off a day on the paper chain, because they need to see that. And they want to know, but they can't quite understand unless they see it.
Yeah. That's good. Time is abstract, isn't it? And yet every adult gets pretty good at it.
I wonder how many runners are in this group, and we calculate how many miles we've run, or how many 5Ks we're running at once.
Yeah, but Americans are so bad at metric, but apparently not when it comes to 5Ks. Yeah. So what you guys are defining is that math is a very broad idea, mathematics. And Kirsty, talks to us all the time about how people confuse math with calculating, and they aren't the same thing. Calculating is a subset of mathematics. And when it feels like it's the most difficult part of mathematics, it's probably because the symbology or the words aren't grammatically familiar enough with you yet that you just can embrace their meaning. And so it's being that kindergartner and being stymied because you just don't quite know enough yet. But you know that you will get that if you keep at it, you'll get it. It'll be okay. So
good.
So how about some really fun ideas about zero? Beth brought one up about dividing by zero. What else? Anybody have other ones?
I always like the example of, you take a piece of paper and you fold it and then, cut it, so you cut it in half and then you cut it in half and you cut it in half and you cut it in half. You can't ever not still have paper. Like it's still there. You can't ever get to zero.
That's Zeno's paradox.
I love it.
Nice. Yeah, good. Yeah, so you can't make the paper be nothing.
Because it is something.
It is.
It's always something.
What else?
I like the idea of zero holding power. When you're using it like to the power of zero, it's going to be 1, and like that zero holds power. It's not nothing.
Yeah. Right. So is there ever a time? Oh, go ahead, Donna.
Oh, I might be going on a limb, but like if you think of zero as darkness as zero, it's so easy to infiltrate it. It's so easy to change it. Like even like just at night when it's as dark as it can get in the house, just one little light on the other end of the house takes away that zero. It's so easy to change.
Yeah. Yeah. That reminds me of a math problem where we ask you guys, what's the number that's closest to 0? What's that little bit that's not 0 anymore? Like in the light and the dark. I don't know. Right? Because it's not 1 or 1/10 or 1,000th or could it be
9
one
repeating?
Yeah. Could it be 1 infinity-ish? But that's an interesting question to talk about when you talk about teaching your kids more or less, is then to take some decimal numbers and compare them to their whole numbers and see how close they can get to the whole number, both from the right and from the left on a number line. Oh, Sarah Walker, explain what you just said there.
Wow.
Sorry, I wasn't expecting to be put on the spot.
Oh, no, that's good. You know, every number. Yeah.
Yeah. And I see that Melissa Poole posted right before me that that's what's asking what the largest number is. And my kids love that game. They're like, which number is the largest? And they'll just keep going and keep going. And then of course, nobody ever wins. But I feel like that's a similar question, right? If 0 is not a number, if it's a concept, then every single number, because they have to be linear, right? It's a linear idea, numbers. They have to be the same distance from an eternal idea like 0. Makes sense?
Yeah, that's really interesting, because when you look at it on a number line, that isn't, I would say that's not true, but what you said is true. So that brings up something that's always interesting to me, is the circumstance in which we're discussing mathematics. So if you're talking about pure numbers, what you said is right. But as soon as we get into one dimension and we have to describe what's going on in relationship to a length, now 0 gets grounded, because then you have a specific distance away from it, and that's the length of your segment or whatever you're measuring. So what's interesting to me is how often parents will say, my child needs to move ahead, or they just seem to rush their kids into the advanced math subjects and don't really spend time in arithmetic, which is where the best of it all is, and getting to know 0 and getting to know 1 and getting to know some of the crazy arithmetic that can happen when you try to use 0 and 1. And there's all kinds of things online where you play arithmetic games and values occur that shouldn't occur. And we have a few of those in the Math Map, not so much to confuse anyone, but to give them a place of discussion where they'll say when is 0.9 repeated equal to 1? Things like that. And you can actually divide by 0. You divide by 0 in 2-dimensional space, but you can't do it in 1-dimensional space because all of arithmetic falls apart. But in 2-dimensional space, you couldn't have a completely vertical line if you couldn't divide by 0, because the slope is divided by 0, and that gives you infinity. And so to say something divided by 0 gives you infinity makes it crazy to do arithmetic, yet it works in geometry. It gives you a 90-degree angle. So I'm throwing just a lot of different ideas out there, and all that I'm describing is in the Math Map somewhere. So there's these points of discussion for you to have with your family on how it's just the richness of numbers and the ideas that go along in manipulating them. So any more comments?
That. Well, just to kind of segue into the last couple minutes, we probably have a couple minutes left. Just some questions about, what does this look like in a CC community, and how does this translate into college? And, so maybe just kind of a quick synopsis, of what does this look like in CC community? What are we doing right now in the future of Math Map, maybe?
Okay, I'm happy to answer that, and we'll keep answering it every week because there's a lot of people that want to know the answer to those questions. So when it comes to high school transcripts or college entry or expectations from the world, we will do what I say for everything else. We'll write an article. We'll help you understand how to make the translation from classical and Christian education to those hoops that sometimes you want to jump. And then when it comes to actually how's this work out in the CC community, right now we're piloting, and I'm guessing a number of you on here are helping us with the pilot across the United States. So we have one more year of piloting. And they're doing challenge A, the complex level, which if you had the math map back up on here, you would see it's the tan in the middle. So it's not going to be available to the general public this coming fall either, but the following fall, challenge A will have the complex math map domain as where the students will be studying. So we are pretty much out of time. So I'm telling you, it's 2 years. And then hopefully within a very short time after that, we already have the kindergarten first grade level out. We call it, for the Abecedarians, we call it, that's what's on the CC Connected. We call it Naturals. And just so you know, it's meant for you. It's not meant for your children. We want to get as many parents on the same page as to what the order of math is and how the math map works, so that as your children ask questions and become curious about math or struggle with math, whatever the case may be, you feel more secure about math education. What we don't want you to feel like is math is about your head down, flipping a page quietly on your own. Math is about wrestling and talking to people and knowing where you're going. It's a similar pathway as it is to get into the scriptures really well. And so we just want to change the way people look at math education. And that's going to take a long time. So you're going to have to hang in there like 20 years. So it's not for you or your kids. It's for my great grandbabies. Because I already got grandbabies. Okay, so we got to be patient. It's some work. It's different, but we will have so much help to help you do well in it. Okay, so with that, Julie, thanks for moderating. Everyone, thanks for being here. I want to say, learning the language of math helps you see the unseen. So let's take advantage of your CC membership and prepare yourself to redeem your love of math. See you next week.
See you next week.
Bye, everyone.
Good night.
Good night.